Here we have a right triangle, ABC, with hypotenuse AC as 10, altitude BD is 6, and we are asked to find the area of this triangle. From what I know, many people try to solve this problem and they were very successful for many years. So they would simply take the side AC10, multiply by BD6 and divide by 2 and be done. And everyone was happy. Until one day. Somebody said that this is wrong. And why is this wrong? Well, you can apply the formula for the area of the triangle only in the case when the triangle actually exists. This particular triangle turned out not to exist. Why is this the case? Well, to see that, let's just put a circle around this triangle. And notice in this circle, angle B is an inscribed angle. And we know by inscribed angle theorem or by Thales theorem, in particular case when this angle is 90 degrees, that AC has to be a diameter and point O is the center of the circle. Now, if you're not familiar with either inscribed angle theorem or Thales theorem, I left a link where you can go and see the details. But if O is the center of a circle, AO will be 5, OC will be 5, but also OB will be 5. But now look at the triangle OBD. This is a right triangle. Its hypotenuse is 5. Its leg is 6. But we know from Pythagorean theorem actually that the largest side in the right triangle is hypotenuse. So this kind of numbers contradict that. And that tells you that, well, this is an impossible situation. And the reason why we got impossible situation is because we assume that this angle B is 90 degrees. So how can we solve this problem? How we can actually modify this problem and make it interesting? One way to salvage this problem is, for example, to keep this angle B of 90 degrees by change the altitude. As you can see from here, the altitude cannot exceed 5. So, but we can put any value of 5 or less, and we'll be good. The other way is to keep the altitude of 6, but remove the restriction of the right angle for angle B. And that brings a question, interesting question. What's going to happen if we remove that restriction? What kind of angle we can get? What kind of values for the angle B we can achieve? What's the maximum angle we can achieve? What's the minimum angle we can achieve? So let's investigate that. So let's look at our problem again. Now we're not going to assume that this angle at the top of 90 degrees. We will say that this length AD is x. In this case, length CD will be 10 minus x. We're still going to have altitude BD of 6. Now we're going to denote the left part of angle B as alpha, the right part of angle B is beta. And we're going to look at two right triangles, triangle ABD with an angle alpha and triangle CBD with the angle beta. What we can do now, we can relate the angle to the sides of those triangles. For example, for triangle ABD, we know the tangent of angle alpha is the ratio of opposite leg, which is x, to the adjacent leg, which is 6. In a similar way, tangent of angle beta will be 10 minus x, opposite leg, divided by 6, adjacent leg. We are not really interested in angles alpha and beta by themselves. We're interested in angle B, which is sum of those angles. But we know that tangent of alpha plus beta can be expressed through tangent of alpha and tangent of beta using this formula. If you're not familiar with this formula, there's a link below. So now we just plug these values instead of tangent of alpha and beta in this formula and simplify a little bit. And this is what we're going to get. Notice that tangent depends on x, so our angle B will depend on x. To see what's going on here, let's do what's called completing the square to the denominator. This is what we're going to get. And now we can clearly see that the tangent of angle B is a positive number. And since it's positive, it means this angle B is really between 0 and 90 degrees. In the range between 0 and 90 degrees, tangent is monotonically increasing function, which means that when tangent goes up, angle goes up. In fact, when tangent is 0, angle is 0. When tangents start going up from 0 to plus infinity, the angle goes from 0 to 90 degrees, which means that the angle is going to be the largest when we have the largest tangent. The largest tangent will be when we have the smallest denominator. And smallest denominator will be when this term, x minus 5 squared, is the smallest, which is 0, which means that x equals to 5 is the point when the tangent is the largest and angle B is the largest. X equals to 5 means this point D is in the middle of the side AC. In this case, tangent will be 60 over 11, and that means that angle B will be about 79.6. So it's less than 90 degrees. Now, when we start going away from 5, either to the left or to the right, the first term in denominator, x minus 5 squared, start growing, denominator grows, and tangents goes down. The angle going to go down. So when the point D reaches either point A or point C, when x is either 0, 10, tangent will be 60 over 36, and that corresponds to angle B, approximately 59 degrees. If you look at this formula, we can continue going either to the negative values of x or values of x greater than 10. And if we do, this is kind of the profile we're going to get. So horizontal axis is x, vertical axis is angle. So what happens here when x goes to minus infinity or plus infinity, if you look at this formula, tangent goes to 0 and angle goes to 0. Now obviously there's a good question, what does it mean for x to be below 0 or above 10? So that really means that point D is either to the left of A or right of C. So for example, when x is negative, our triangle ABC is going to look like this, and point D somewhere to the left of A. We solved this modified problem, but the original question remains. Normally, when somebody gives you a problem in geometry, you don't expect that it's going to be a trick problem. You assume that, the geometrical construction they're talking about is correct, it exists, and all you do is to find what they ask you to find. So when somebody gives you a problem like this with angle B of 90 degrees, for example, should you check for the existence of this triangle? Or should you just assume that triangle exists, the teacher is right, professor is right, and just simply find the area of this triangle? And if you do, should you get a full point, full credit? Well, if you have any ideas, leave a comment.